Hello students, welcome to classroom. In today's lecture, we will be discussing about hypermetropia, which is the other eye defect. The first eye defect, which was myopia, we have discussed in the previous video. So in today's video, we will be talking in detail about hypermetropia, the causes of hypermetropia, and then also the correction for hypermetropia. So my suggestion to you will be, my dear students, is to master the myopia first, the eye defect myopia, which has been covered in the previous video. So if you understand myopia better, then this will be very easy for you to understand, because it will be the opposite of myopia. Hypermetropia and myopia, they are quite opposite of each other. Myopia is short-sightedness, which means a person suffering from myopia can see very well near object, but myopic person cannot see far object. Whereas in hypermetropia, the defect is also known as long-sightedness. That means the hypermetropic person can see far very clearly without any problem, but the hypermetropic eye cannot see near object. So you see that both myopia and hypermetropia are exact opposites of each other. So if you understand one very well, okay, understanding the other will be easy because they work opposites. So this is what I want to tell you, that to first understand one thoroughly, and then if you understand one thoroughly, this will be very easy for you to understand. So having said that, let us start the discussion and let's continue with the class. So hypermetropia. Now what is hypermetropia? Let us first start with the definition. So let us write the definition of what hypermetropia is. So what is hypermetropia? Question mark. So like I just said earlier, that hypermetropia is a defect of the eye in which a person has no difficulty seeing far objects but has difficulty seeing nearby object. That is why this defect is also known as long-sightedness. So hypermetropia is also known as long-sightedness. Long-sightedness. Now why is it called long-sightedness? It's called long-sightedness because the person suffering from hypermetropia can see far, but the person cannot see near. Okay, so that's why it's called long-sightedness. Now one simple hack to help you remember, my dear students, in the exam will be the spelling of hypermetropia is longer. Okay, so long-sightedness. Okay, whereas myopia, the spelling itself is short. So myopia, short-sightedness. Short spelling, short-sightedness. Hypermetropia, long spelling, long-sightedness. Okay, so you have to be fluent with this. Okay, so do not get confused between these two. Make sure that you are thorough with the difference between myopia as well as hypermetropia. So let us write the definition of what hypermetropia is. So what is hypermetropia? Hypermetropia is a defect of the eye in which a person can see far objects clearly. Okay, let me just shorten the definition by writing clearly. Okay, it's a defect of the eye in which a person can see far objects clearly but has problem seeing nearby objects. So this is the definition of hypermetropia. It is a defect of the eye in which a person can see far objects, but the eye cannot see nearby object. So the person has difficulty seeing nearby object. So if you have this problem inside a classroom, you will have problem seeing the whiteboard. Okay, even though you may be in the front bench, okay, whereas you will have no problem seeing far distant object. So this is what hypermetropia is, okay, where the near vision is bad but the far vision is quite good, okay. So this is the defect. And then some important things that we need to know here is that in myopia the image was formed before reaching the retina, okay. Here in hypermetropia it will be opposite of that. So here in hypermetropia the image is formed beyond the retina. So another important point here the image is formed beyond means crossing the retina, beyond the retina, very important. So in hypermetropia the image is formed beyond the retina. All right, so now let us discuss the causes. So there are two causes, just like in myopia there are two causes. Now in myopia the problem arose because of the curvature of the eye lens. So in myopia the problem was that the eye lens was very curvy, okay, very curvy. That means it was very curvy. Having a big curvature, okay, brings the focus nearby, so the bending power becomes very strong. In hypermetropia what happens? The curving power, the curve decreases. The lens is not able to curve. So the problem here is weak converging power. Okay, in myopia it was very strong converging power, very quick converging power because of the great curve of the eye lens. But in hypermetropia the lens is not able to curve efficiently. So here the convergence is rather very slow. So we have weak convergence power. So which means decreasing power of eye lens. So cause number one, cause number A, decreasing power of eye lens. Decreasing power of eye lens. Okay, decreasing power of eye lens. So the eye lens, okay, the eye lens power is decreased. Okay, how do we know that the eye lens power is decreased? Because it is not able to bend the light rays, okay, quickly. So here, not being able to bend the light rays, what will happen? The light rays will take more time, thereby taking more time the focus is extended. So here we have long focus, okay, the focus gets longer here. So in hypermetropia, in this very point we can say focus gets longer. So we can also write focus gets longer. Now how did the focus get longer? The focus will get longer when the lens is not able to converge the rays quickly. Okay, so normally let's say the lens is here and then the focus is here, okay, or let's say the lens is here and then the lens has got good converging power. So where will the rays be bended? At the focus. So this is normal, so it should be bending here, okay, here. But then if the lens is weak, if the converging power has decreased, then what will happen? The lens will take the rays will take more time and then they may even meet here. So here, see, the focus has increased, yes or no? Okay, so in simple way, in simple term, we'll discuss more again in the very soon. So I hope you got what I'm trying to tell you here, that let me just show you. So normal lens, let's say, so they converge here. So this is the focus, okay. Then again, now this is hypermetropic, okay. So the lens has got weak converging power, so same rays coming to the lens, okay, but then here they will converge here. So now you check the difference, or check out the distance, okay. Normally at this distance the rays get converged by this eye lens, but in hypermetropia, because of the weak converging power, okay, the convergence is happening at this point. So you can see there is an increase, is not in length, okay. So this is basically what is happening. This is basically what is meant by focus gets longer. So normal focus is here, hypermetropic person focus is here, okay. So there is a increase in the focal length. Okay, this is happening because the eye lens are not able to quickly converge the rays. All right, so this is first point. Okay, so in hypermetropia, the power decreases. All right, the power decreases because the focal length increases. Okay, so decreasing power of the eye lens means, so power is decreasing, so focal length will increase. After all, the relationship between power and focus is this. Okay, if power increases, focus will decrease. If focus increases, power will decrease, because they have an inverse relationship. All right, okay, so this is the first point. The second point, point number B. So in myopia, one of the reason was the elongation of the eyeball. Okay, for which having longer eyeball, the rays were not able to meet at the retina. In hypermetropia, the opposite will happen. In hypermetropia, one of the reason is shortening of eyeball. So point number B, the second cause is shortening of the eyeball. Now let's have a look. Now, what is this shortening of the eyeball? So let's draw an eyeball here. Let's say, let me draw an eyeball. So this is normal size eyeball. Okay, so this is our lens, and then let's draw the object here. So object is nearby. Now from this object, the light rays will appear like this. Okay, so a normal healthy eye, where will these rays meet? The eye lens will converge, and then they will meet at the retina, which is also the focus. We already know that, isn't it? So we know that the convex lens converges at focus, so this becomes focus. This also becomes the image distance. This is for normal. This is for normal eye. All right, so this is for normal eye. Now let us draw for this one, shortening of the eyeball. So normal size eyeball is like this. Okay, so we will now, I will draw a smaller eyeball. Let's say this is much smaller than the normal size, and then the lens is here. Now I will draw the lens of the same curvature. Okay, and the object is also here, same distance. Okay, rays will go like this. Rays will go like this. What will this do? This, okay, this will converge. So the eye lens will converge these rays. So let it converge the rays. So now it will converge. It will converge. But you see here, where is it meeting? It is going beyond the retina. It is going beyond the retina. Why is this happening? This is happening because the lens thinks that, okay, that the retina is here. The lens thinks that the retina is here, because normally people retina is here, is it not? Okay, so the size of this eyeball and the size of this eyeball. So the lens, being normal, assumes that the retina is here, just like any other normal healthy eye. But then in this case, the eyeball is small. Okay, so the eyeball being small, the retina is here. Okay, but the lens thinks that the retina must be here. Okay, so this is what is meant by shortening the eyeball. So if the eyeball is shortened, the rays, okay, they meet here. Okay, they meet here. But since the eyeball is short, unfortunately the retina is not here, rather it's a little in front of it. Okay, so this is what is meant by shortening the eyeball. Okay, so this is the hypermetropia, hypermetropic eye. Okay, with shortening of the eyeball. So these are the two causes: decreasing power of the eye lens, okay, and the other one is shortening of the eyeball. I hope you all wrote it down. So now let's erase this and go to the correction of this defect. So let's go to the correction for the defect of hypermetropia. So like I said earlier, if you have understood myopia, hypermetropia will be easy, okay, because it's quite the opposite. they are quite the opposite of each other. Now, correction of hypermetropia. So let's study the correction together. So correction. Now, what will be the correction for hypermetropia? See, let us first diagnose the problem. Let us diagnose the problem, and then the answer will come automatically to us. So the problem with hypermetropia is the weak converging power of our eye lens. So our eye lens have become weak. Since it is not able to, since it has become weak, that means its power of convergence has decreased. So it's not able to bend the rays effectively. So what type of help does the eye lens needs? It needs someone who will help converge. It needs a type of lens who will help him, okay, converge better. So which type of lens do you think will help our eye lens? Yes, it should be a convex lens. So the correction is by using convex lens. So by using convex lens. So we will be using convex lens. Okay, let's see how by using convex lens this problem is diagnosed. So here is our eye. Let me draw a bigger one now. Okay, so this is our eye. Then our lens is here. Okay, then the object is here. Okay, so this is the weak eye. Okay, let me just show you one picture. This is, I'll draw again the hypermetropic eye. Okay, before I draw the correction there. So since there is space here, let me show you. So the object is here. Okay, then from this nearby object, now light rays will diverge, and then whether it's case 1 or whether it's cos 1 or cos 2, what happens here? The problem is it will be formed here. So it's formed behind the retina. Alright, this is the problem eye. This is the hypermetropic eye. This is the hypermetropic eye. Okay, now let's correct this. So in order to correct this, let me draw the eye lens again. Okay, and this is our lens. And without correction, the image will be formed here. Okay, but we want, okay, now but we are going to correct this eye lens. We're going to correct this. We're going to help this eye lens. We're going to correct this defect, and we will make the image form at the retina. So what we do is we take another convex lens. So we bring another convex lens, and then the object is still here nearby. Okay, nearby. So now from here light rays will go like this. Light rays will go like this, and then this will already converge. This will converge it for him. So our eye lens, this one being weak, okay, being weak, this lens has, this convex lens, this external convex lens has already converged the light rays for this eye lens. Okay, so now our eye lens, which is present inside our eyeball, need not do much, because the rays have already been converged by this external eye lens. So this convex lens has already helped bend. Okay, if you're not seeing the bending more, let me just make the curve a little more better. So let's say it goes like this. Okay, so it has already helped in bending. Okay, if our eye lens was healthy, this bending will be done by itself. But since this eye lens is weak, it's not able to bend effectively, because of which the rays, they take longer time, the focal length gets extended, and then they meet behind the retina. So in order to correct this, we have to prevent the rays from going here, but then we have to make sure that the image is from here. So we have to bring the focus closer to the okay, we have to shorten the focal length. So who will help us? This is helping us. So now the rays coming from the object has already been curved, has already been converged, and then all our eye lens has to do is just do fine adjustment. Okay, just do some fine adjustment and then guide the rays. Okay, guide the rays to the retina like this. So what happens? Now the image is perfectly, okay, the rays are meeting perfectly at the retina. So has the defect been corrected, class? The answer is yes. So with the help of this external convex lens, okay, the image has been now rectified, and it will be formed at the retina. Okay, so this is how hypermetropia is corrected. So this is correction. Okay, and this is the convex lens that we're using. So convex lens has been used, and this is the corrected. This is the figure. It will be the corrected eye. So that's how the doctor will correct your hypermetropic eye. Okay, so the doctor will let you wear convex lens, and with convex lens, okay, you'll be able to see now. Well, you had no problem seeing far from before. Now with this, you'll be able to see nearby stuffs better again. Okay, so this is it, class. Okay, so this is the topic hypermetropia. We have discussed the definition, we have discussed the causes, and we have discussed the correction. Basically, this is what you have to study: the definition, okay, the causes, and the correction. So together this is a 5-mark topic. So it was easy, isn't it? Okay, so yes, it was easy. So these are not very difficult topics. So now, before I go away, so I have one question for you. So I'll write the question, and I would like all of you to comment the answer in the comment box. The question is easy. Okay, so let me write the question for you. Question: the focal length of the eye lens increases when eye muscles, comma, the options are A, are relax and lens become thinner. Option number B, contract and lens become thicker. Option number C, are relax and lens become, what is it, thicker. And option number D, contract and lens becomes thinner. So class, this is the question. So the focal length of the eye lens increases when eye muscles, the options are A, are relaxed and lens become thinner, B, contract and lens become thicker, C, are relaxed and lens become thicker, and D, contract and lens becomes thinner. So which is the correct answer? You please comment in the comment box. Okay, so this is it, class. I'll see you again in the next video. Until then, take good care and God bless you all.